Okay, we are live. So as I was saying,
problem.
today what we're going to look at is the Vixra.
But I am tired to not make problems because I am a little tired.
That's fine. It's up to, whatever you feel, Laszlo. You don't have to interact as up to whatever amount you want. It's fine, perfectly fine. So it's just going to be easy going, just a bit of a informal, sort of relaxed conversation here about the subject of Vixra, which I'm going to get into that now. Just give me a few seconds. And so the first thing we want to look up is Vixra. So I figure the way we'll go about this is to find some info about it from Wikipedia. Maybe that would be a good thing to start with, and then also go to the actual website.
I have a Wikipedia, but it was broken. I don't have no Wikipedia. My Wikipedia was broken before 3 months ago.
Oh well, how do you break Wikipedia? Is it not a website on the internet? I mean, it's
perhaps I will make another.
Oh, you have one about yourself, is it? Under your own name?
What breakout? Some hacked.
Oh.
It was hacked.
No way.
My Wikipedia.
That's interesting. Maybe it's on the far back machine.
Not Wikipedia, no, LinkedIn. Oh, excuse me.
Way back machine.
LinkedIn was hacked.
So the what was hacked?
LinkedIn, yes.
Link.
The links.
LinkedIn.
LinkedIn. Yeah.
Oh,
yes.
LinkedIn.
Yes.
Ah, you're on LinkedIn
Wikipedia,
as well.
Wikipedia.
Okay, so this is Vixra. They're talking about it here on Wikipedia. It's an electronic e-print archive known for unorthodox and fringe science. It's set up by an independent physicist, Philip Gibbs.
Yeah, okay. I don't know. Okay. I am.
Can you see what I'm showing here? Yeah. Yes.
Wikipedia. Yes, I confused with LinkedIn.
No problem. As an alternative to dominant archive service operated by Cornell.
I know.
So there's the archive. We all know that. It's kind of, I don't think this is peer reviewed, but you need to be referred by someone in like physics or mathematics in order to publish on the archive, if publish is the right word. So although dominated by physics and mathematics submission, Vixra aims to cover, I'm assuming I'm saying the name right, it could be Vixra, aims to cover topics across the whole scientific community, accepts submissions without requiring authors to have academic affiliation and without any threshold for quality. So basically, there's no peer review on this site, so we could look at a few of the papers on there and see, maybe just give it a bit of a review, because we're also not on I'm not on archive anyway, so we might as well consider ourselves peers. Anyone may post anything on Vixra, though house rules do not. Okay, well, that's just normal. As a result, site has a reputation among physicists for posting material of no interest. Okay, we'll have a look at that. Gerhard de Hooft writes, when a paper is published in Vixra, is usually a sign that is not likely to contain acceptable results. It may, but the odds against that are considerable. Okay. Gibbs originally started the archive to cater to researchers who believe that their preprints were unfairly rejected or reclassified by the archive moderators. As of 2013, it was over 4,000 preprints, and by December 2020, the number had grown to over 36,000. 2020 study of preprint servers found that as of September of that year, Vixra hosted 440 reprints about COVID-19. Okay, because, well, that makes sense because 2020 was the year. I'd say they'd be interesting. Vixra uses the same article numbering system as archive. Okay, that's just not that interesting. All right, so we'll look at, so we have, this is the website here. You can donate, apparently. We're not going to do that, though, but not yet, anyway. So you have all submissions, which is now totaling over 43,000. And then, so these are the different topics. We've got physics, mathematics, computational science, biology, chemistry, humanities, academics. So I think we're going to focus mainly on physics because this is a physics channel. So high energy particle physics. Now, this is the one I'd imagine is difficult to do from your laptop at home, you know? So I guess it could be sort of theoretical. Quantum gravity and string theory. So there could be some interesting things there. Relativity and cosmology, also pretty interesting. Quantum physics, nuclear, dense matter, geophysics, there's stuff there we can look at. And climate research, mathematical physics. Well, that sounds kind of that's our sort of domain. I think quantum gravity maybe, and relativity and cosmology. Okay, so recent submissions. Unified field theory by Zhang and Zhu, and Earth's magnetic field model using a variable speed inner core. Might look at. So how does this work? Do we have to download the PDF? Oh, we do. So magnetic field reversal, paleo magnetic record. I'm wondering why this isn't in the geophysics one. Maybe you can be in different sections at the same time. Geomagnetic phenomenon, geodynamo theory, solid inner core. Okay. Off-axis magnetic field. Right, so it's a pretty short paper. So reflections on methods of representing the terrestrial gravity field. Reflections of the colleague Abdelkader Salal on methods of representing terrestrial gravity fields and its proposals on the subject to encourage young geodesists to discover these methods. Sure. Okay, so these are sorry, we are in the geology thing. That's why that's class. I should have paid more attention to my tabs of what order they're open in. Here we go. This is which one? This is mathematical physics. This is more. We can come back to the geology one later. I didn't want to start off with it though. Flow of power law fluids in tubes of elliptic cross sections. I've looked into that kind of stuff before. 4 space-time dimensions from Rennie entropy. I don't know what that is. Have you heard of that, Rajan?
Not. I don't know very specific. I mean, it's maybe like based to fractal physics or something.
Oh yeah, there is.
I have not used it.
Yeah,
but I have not gone through it. It may be the entropy associated with, the fractals versus this thing, but that's something we have to look into. Fractals.
That's really interesting concept.
Fractal dimensions.
Fractal entropy.
Yeah, fractal dimensions versus
of
normal.
Course, yeah, fractal dimensions. That is interesting. On complex dynamics and classical field theory. By the way, guys, yeah, you can. Oh yeah, well, I suppose I have to. So Ginzburg-Landau equation. Landau was also working a lot in entropy, wasn't he? But he's probably got a lot of.
Yeah, I think some in superconductivity, something.
Yeah, he's probably. This is the Navier-Stokes equation again. So, if there's any one that you're interested in looking at, let me know, and we can can do a more deep dive on it.
Alternate solution to black hole information paradox.
Oh, an alternative solution to, yes.
Excuse me, but in case of black holes, I think perhaps imagination, you have to imagine in other way the black holes.
Okay,
the black holes may be interpreted as a giant planet, exactly like Earth.
Yeah. So
after despairing the finishing of final stage of solar light, our sun, it can become like a rocky planet, and in science physics it will work as a black hole.
Oh, I understand. So it kind of
because we see from big distance, nobody knows what is there, but can be accepted in sense natural, that being similar like a rocky planet, like our Earth.
Oh, okay.
That is totally new idea. This is not written in literature.
Yes. Okay, but so the Earth is, what's the difference between it and the Earth? Because it obviously a black hole has very high gravitational field and the Earth does not.
If example, if our sun became, or an galactic nucleus became such a big Earth-like type celestial body, then can you imagine that same the gravitation it has a bigger, like in case of Earth, and it cannot emission light. It has not will have light emission.
Oh, okay, yeah.
Our Earth same doesn't have light emission.
Well, because, well, it's not like a star that's emitting light. The Earth isn't emitting light. It's reflecting light, though, isn't it? Whereas a black hole, you wouldn't expect a black hole to reflect light.
Because one thing is very important: how an object is bigger and bigger, they has his physical properties become slower, and something different when is small. In case of smaller, if you take example an ant or an elephant, is a biological thing, but in physical thing, it seems that works similar somewhere. One thing is very important in the case of natural phenomena, but is in every other place they develop in same properties. Only some of the main things of natural phenomena is very similar, but only they seems something different, but in general we have the same phenomena. Example in Earth, is a similarity with the Earth attack. Earth not how we can tell this Earth attack. Earthquakes and Earth attack is a similar phenomenon.
I understand. Yeah, heart attack. Yeah.
And the same I told about before about this, that similar conclusion has Slav Nagorny. And I told that I will send you his work, but
Okay.
it's not. It only one side of the phenomenon he got, because in mainly time we have to count with two sides, like ancient philosophy, yin yang. That is every time is the same in all processes in nature.
Okay, so I'm not.
This was very simpler.
Okay, I'm not too clear. What does the what does a heart attack have to do with the black hole, rocky Earth thing?
Earthquake.
Yeah, that is not.
Earthquake. You're meaning
I went black hole only the only that the black hole is. I don't accept their existence. How is it in literature? Because
Sure.
that can be because his extension cannot produce that phenomena which is given for it, because it's a very extended quantity of matter is made that it contain it, and physically such a object cannot be produced.
Well, I mean, what is the basic idea behind a black hole? A star that gets very large.
As only seismically, only with seismical phenomena has connection. Earth attack is similar with stroke, with stroke, and with the Earth attack. That has similarity is in case of example in as I told before, that Earth, and in quote that black holes, in quote, that is in this case it has other meaning. And the example in comet same can be concepted as is similar with the Earth type body, celestial body.
Okay. Yeah, well, because I've heard the concept that an earthquake and a heart attack have similarities, but yeah, I'm just not seeing the connection between the black holes here. Well, I mean, you don't believe black holes exist, but a black hole.
Black hole, as I told you, accept existence of black hole, but not in sense as it is described in literature.
Okay, yeah, that's interesting. Okay, well, I don't know, Rajan, do you have any?
Yeah.
Any points you'd
so
like to make?
let me. I have, let's say, two aspects. One of them is I will accept, or I'm open to discussion about how Earth could be like a black hole. So we are living in a black hole kind of thing. Right. Black hole is very rich and everything. The only problem that you pointed out is also I have the problem of gravity. Because black holes have immense gravity. Earth does not have that level of gravity. So how do you reconcile to that? How do you reconcile to the fact that Earth has such a low gravity? The only thing I can think of is the structure of the black hole may be more complex than we think. So which means that very much inside the black hole, it could be low gravity. It could be almost like vacuum of very low gravity.
Well, it could be another universe, couldn't it, Rajan?
Another universe. So outside the black hole could be very high gravity. So we should be able to test either the solar system somewhere, there should be very high gravity associated with the black holes. That's what, if we can find that, and then that directs towards Earth, which means Earth is very close to the center of gravity of the black hole, but inside the black hole, that gravity is low. Right. I mean, that's a complex system. If that is proved, I think it could be considered gravity, because I think inside the gravity there could be a rich structure, like fractal structure,
Right.
things like that.
Yeah. And also, I mean, Laszlo makes an interesting point. I mean, you could imagine maybe that the sun.
Yeah.
I mean, you know, just I'm not sure if Laszlo is making this point, but like the sun could be like a high, like if we were to move up in some sort of frequency, would the sun solidify into a rock? You know?
Yeah. Yeah.
Like it could appear, like depending on how we're looking at the sun from like what frequency vantage point, if you like, that the sun could solidify, and then we'd see that all of the movement that's happening on the surface of the sun are actually cars driving along and people going about their daily life. I think we discussed this before on a previous. Yeah, so I'm interested in that idea as well, because I think I spoke to someone actually about that concept here. We were talking that maybe it was sort of a dream that someone had where they were looking, or well, so I had a dream where I was on the surface of this planet, and there were all the Greek philosophers were there. You know, it was like kind of a Colosseum sort of courtyard area, and we were hanging out, and they were pointing out the stars above us, and there was Jupiter and like Venus and stuff. And then I don't remember who said it was either one of them or it was me, but I could point to a planet and say, and that's Earth, which meant that we weren't on Earth. So, and we figured out that we were on the surface of the sun instead. And then somebody else had the exact same dream where they figured out that they were on the surface of the sun. They met all these Greek philosophers, and they were telling me about it. And I was like, oh yeah, I've had that dream as well. So the point is that in another kind of dimension of, or on another frequency of seeing, the sun could be solid, you know. So
also people think it's metalloid, right? Like a lot of metalloid things in sun.
Yeah.
So there was a theory, I think, it's associated with high level of iron or some kind of a metallic thing associated with the thing.
Well, there is the idea of the liquid sun, which I think
liquid
is really
sun. Yeah, liquid in the liquid metals or liquid form.
Yeah, it's some sort of metal, isn't it? Is it carbon?
Yeah.
No, it's not carbon, but it has
iron. Probably. Is it iron? No.
Yeah, it's some. I don't think it's iron either, but it's got a lattice. Is it helium-3? Liquid helium-3, maybe?
Could be. Yeah, that is like a metal. Helium becomes like a liquid metal.
Yes, liquid metal. Yeah, because presumably it's under very high temperature and pressure, so it could exist in that state. I think that's the theory by Robert Bataille or something like that is his name, French physicist. And he was talking about that back in the internet like decades ago. Really interesting theory. And then more recently is this Alexander. Oh, I've forgotten his name. Unzicker. He talks about that a lot. I think he's written a book on it as well. The liquid sun hypothesis. Yeah, I would tend to lean towards that more. That the sun could be a kind of a liquid. There were some other cool kind of concepts that people came up with, that the sun gives birth to planets, you know, and then they, you know, so Pluto would be the oldest, and then Neptune, and then Uranus, I think, or yeah, well, they cross over each other actually, so it's a bit hard to say. And then you'd have like Saturn, Jupiter, and then the more rocky planets. So the idea is that as the planets move out away from the sun, they start off rocky, and then they begin to break apart and become more gaseous, and then they just fade out of existence. This is a funny idea. I don't know who came up with that idea, but he wasn't a physicist. I'd have to look his name up, but yeah. I mean, I don't agree with it, because I think they've looked at other solar systems now, and they've discovered exoplanets of, you know, very large gas giants orbiting very close to very large stars. So, and that when they discovered that kind of broke their models of how do you say, like solar system formation. And to be fair though, nearly everything they discover out there in the universe seems to break their model of solar system formation. So I think we're a long way off from solving that problem, or at least in the conventional physics sense, or cosmology. And I personally don't have an answer to that problem. I guess the idea of just a gaseous secretion from a disk is probably the one that makes the most sense at this time. But yeah, so I don't know if you guys have any more comments on that, or we can.
Yeah, one of the things in mythology, like even our Hindu mythology, different mythologies talk about the sun gave birth to all these planets, like you say. So it's kind of how they interacted. In fact, that's very important part of the astrology itself. But coming back
Astrology
to
or astronomy?
Astrology.
Astrology. Isn't astrology the one? Astrology is like predicting the future, Rajan. Is that the one you mean?
Yeah. But the planets and everything are looked upon certain connections.
Oh, that's true. Yeah. Very good point. Yes.
And then the sun, is like a father, the big father, and then the planets are, offsprings of that kind of thing. That type of thing.
Yeah. I like. I mean, astrology is interesting from like a computational point of view, and because you have to get all the angles for all the planets, whether it's squares or triangles, whatever angles they create in the sky. But that's a kind of Western astrology. I believe in India you have a different kind of Vedic astrology.
Yeah. Right? Actually, I was with a person who had a vision audio. So we had lessons. I had lessons with him about astrology, how to look at the thing. And I want to connect, it's very fast. I kind of know what it is, but I want to get to more IT. There was another IT person but we didn't have a chance. That person went away. Otherwise, he would have created website type of thing or a program that would, connect. That's how to calculate the astrology, because the declination angle, those are very important. And my nephew is very much into, he actually did predict, because you sit down there and they kind of invoke, through the thing, and that invocation comes, by using certain elements, paraphernalias or elements. He's really good in that. So that's the ultimate thing. So you can tell about what happened to me without me giving much information, and about 70 to 80% was accurate. About 70%, I would say, 60 at least. That these things happen, this happened. Is that true? But he didn't have no information, those details, and that's where true. And what happens next, things like that. So he predicted that I might ascend to a higher level, that the world will have, I will have a great saying about what's going to happen in the world and things like that. So I may ascend to that level. Another astrologer also said the same thing. It's called levels, like 5 levels. So I am like 1, 2, 3, 4, 5. Fifth level is the highest. So I was at the second or third level, but he said I will ascend to 4th and even probably the 5th level at some point. But yeah, so those things, prediction somewhat is correct, because I see like minor things I am writing, and then the particle connection from abstract to thing, firewall, all these things seem to be, I'm looking back, and you can mathematically prove these things all the way to particle physics. That will be, and then connect your hyperspace, and a lot of thoughts now. I'm seems to be working together towards quantum gravity. And the recent paper I sent right now, I think you may have received in RG.
Yeah, I had a look at that.
Yeah. So the correction now, coming back to Laszlo's thing. So one possibility is that you have this Milky Way galaxy, right? Milky Way galaxy, and we know there is a black hole at the center of the Milky Way galaxy. That they're predicting, that big black hole.
Yes.
So Earth could be part of that, well within that black hole aspect. the sun, the solar system, because solar system is at the edge of the galaxy, some kind of a mantle. It's not really at the center or something. It is kind of like a panhandle type of thing, you know. It's at the side.
But it's on one of the spiral arms or
spiral arms, and next to Andromeda. Right?
Andromeda is a separate galaxy.
Yeah, I mean, know. But they could be connected.
Initially, but not with stars.
Not now. So it could be. It is possible that this black hole fractured, and then it created these galaxies, Andromeda, and then our galaxy.
I don't know.
Our solar system.
The black hole is still at the center of the Milky Way galaxy.
Ryan.
Yeah.
If you imagine, example, a rock.
Yeah.
A rock. Example, a granite. Now, how is it inside of this rock are arranged the atoms? You can imagine like this the universe, the bigger galaxy. How are in universe? But in the case of universe, the connection is not so fixed like in case of rock.
Mm-hmm.
Do you understand what I mean?
Yes.
Yeah.
In case of rock, in case of example, in a ordinary matter, the elementary particles, chemical particles, are fixed.
Yeah.
And in case, if we imagine that we have a vapor, we have an atmosphere. In case the atoms are not fixed, they can move as it possible, and something I consider that is similar in the case of galaxies or in case of solar systems.
Okay, so they kind of
because if we consider our solar system, it has a heliosphere.
Oh yes, a heliopause and a heliosphere. Yeah.
Exactly. And I don't have any information. And where is the next solar system, which is close to us?
Bernard star, I think, is close.
Yes.
There's another one, Proxima Centauri or something like that. Alpha.
Yes. No, and something our solar system, if we concluding that is a example is an atom, and we can concluding that is something similar with the gas, what more freely is this system. How is bigger, is more freely they could like in case of smaller dimension.
Yes.
As it dimension is decreasing, it's become more fixed and more fixed.
Oh. Well, hang on. So, like, if you have, like, you're talking about three-dimensional space, and then if you go down to two, like there's less degrees of freedom or something. I don't understand actually.
I don't understand.
Okay, fair enough. Yeah, I think we might be talking.
That's a brain. I think the brain theory is useful. Like I mentioned about M theory, right, last week.
Yeah.
And then the next one is a brain theory, and that makes a lot of sense to me. Brain theory very close to what John is saying at Hort, and also two-dimensional aspects. So it is like a wrapping around. Instead of a string, it's two dimensions, right? Films. So thin films, and then they are wrapped around. So they form many layers, but they interact. It can create highly complex. So they start curving. they start puckering, and the dimensions, they will start because of the gravitational. There are two things: cosmic microwave background and the gravitational wave. These two are interacting. One of them is more photonic, the other one is more phononic vibration. So these layers start interacting, and they create highly complex extra
Maybe.
dimensions, probably.
Yeah.
Extra dimensions.
I don't know. I mean, it's hard to know. So here we've got another one, unified gravity through repulsion graviton space model. So the repulsion graviton space model, gravity model, proposes a unified gravitational theory that explains galactic dynamics, cosmic accelerated expansion.
No, one thing I would like ask you, and in case of white graviton, what is your opinion?
Well, do you mean, do I think they exist or not, or?
When I made the term of graviton, that is, and Ryan has a similar something similar with the micro black hole.
Oh,
yes.
Yeah.
I have saw in his work.
Yes.
And it can be considered that the two thing is similar.
Okay. Yeah,
and that is why I thought that there is Ryan have to imagine in case of black holes in a cosmic scale that exists contradiction in a micro in a elementary black hole and the cosmic black hole. If you accept the existence of micro elementary quantum black hole, in case of cosmic black hole, it cannot be it's not concordant. They think.
I see.
Is that because you think that like a black hole, like a cosmological black hole, would have to be made out of tiny black holes?
Black hole, somewhat you can, in case of black hole, somewhat you can imagine an absolute nothing.
Yeah.
Absolute nothing. And in case a cosmical dimension, absolute nothing is someone different, like in case of but you can absolute nothing doesn't exist. That is we have to accept first.
I will think about that. That's a good point. So one of the things about a graviton, let me talk about, because there is a paper in the peer review now, very important paper. I think Christopher already knows. I went through that my analysis of the spin spectroscopy. I call it spin spectroscopy. So I plot E over M, which is a fundamental particle character, E over M, the charge over mass, versus the spin of the particle. So I find that graviton, you can find out there's a connection there. So the way I think something called firewall. Okay. So when we come to that, light cannot pass through a firewall. The sound cannot pass through a firewall. However, my conjecture is that graviton can pass through a firewall. That's an interesting, that's my conjecture. If we can prove that, then it means that the graviton is the big, like Emmanuel is saying, is the ultimate particle that made everything possible.
What is a firewall in this context, Rajan?
Firewall is something that, something that prevents something from going to the other side.
Okay.
So the firewall.
So you're saying, but like, let's say I have a wall of titanium or something that's like 10 feet thick. Then I have like a neutrino or a neutrino, it just passes straight through it. So what point are you making?
Yeah. So for example, suppose you have galaxies, right? Galaxies, it's a firewall that makes them exist because something cannot penetrate The other one, like gamma ray can penetrate, right? Gamma ray can penetrate. But if you pass like some other lower energy ray, it cannot pass through that.
True.
It depends on the geodesics. Like Earth, many rays can pass through, X-ray and other, other lower. Okay, gravitation, even gravitation.
Okay, so what would this? You need some sort of special firewall that doesn't exist in the universe in order to shield all these other things.
Yeah. So
gravity. Is it?
So yeah, what we think is like ultimate thing. Emmanuel, I think probably you also agree about
the ultimate,
superluminar. Yeah, superluminar condensate. We think that initially there is a superluminar condensate, right? The monopoles are moving around, things like that. But then from there, a vacuum is created. From the vacuum, the where the light speed of the light is held constant, then it pops through that. That's where the firewall comes in. Okay, the vacuum itself can act like a firewall, and then it pops through that, and then you have less than the speed of light, like subluminar things happening. That's where the mesoscopic phase is.
Ryan.
Yeah.
In case of superluminal condensate,
yes,
you take again the analogy with the electromagnetic radio wave and the light wave.
Okay.
And if you accept that the space, exemplar in case of our Earth, that is a totally is not is not made from quant. Is it totally how can you explain it? Totally continue. You can accept in this direction, and example in my case, what I in my article, what I put in before 2 weeks ago, there, how we come in close to the Earth, it become more lack of this space, this continuous space. That is because of the Earth rocky shell mantle and
core.
Not core. Rocky shell. Okay, I don't know.
Lithosphere.
Yes. No, that is create this lack of the space entity lack, and that is the cause of our Earth gravity.
So that can be considered like a firewall. The lithosphere can be considered like a firewall.
And in our dimension, this space is not made from quantum. Perhaps in micro exists quantum, but we can detect with our tools.
Yeah.
And that is why at me graviton only in elementary level exists.
Yes.
Only in quantum level, atomic level, only this level, and this plays importance in case of chemical ligature and in creating of light and electro photo effect, all this. Perhaps
that's a very good point. So it's possible that graviton can exist only at high energy physics, high energy level. Lower energies, it condenses to like fermions, bosons, and fermions. So it's possible that graviton
is connected to the electron.
Yes.
The graviton is connected to the electron and the photon.
Yes.
You can consider, like in case of our Earth, that inside we have hydrogen, and outside the hydrogen is a sphere, is a shell which act similar like our gravity field. Only on the elementary, only on elementary level, but this graviton has is like an wave like a photon, because it can be particle graviton and same time waves. Is somewhat this I have imagined it. You understand?
Yes,
exactly, it's like a photon. Exactly like a photon, but graviton is a black hole, or in quoting absolute nothing, and like similar like the photon.
So let me explain.
It has
yeah. So
it has two types.
Yeah. Okay.
Example, the photon is a particle, but same time is a wave.
Yes.
It has a dualistic feature.
Yes. So the way I can think of is like micro black hole, right? Then the graviton acts like a mediator and it converts the bosons. Then the bosons will act like a mediator and then convert to the electrons, the electromagnetic field. So electrons actually. So you have the following things: micro black hole, gravitational waves or gravitonic waves. Then you have
graviton waves. Graviton waves or only the changing of gravity field.
Yes.
Example similar with electromagnetic field. Like
yes.
If we have a change that is appears in radio waves or something similar, and I think that example in changing with gravitational field, that it can be produced electromagnetic field, because fields are connected.
Yeah.
Example
so like
happen on earthquakes. That produce same time radio effect, and I promise to Christopher that I will send the article of Valentino Strasser, which he will, and if you will see YouTube, you will understand that can be accepted the connection between electromagnetic wave and the gravity wave. And that is why I didn't, accept the discovery of LIGO gravity wave.
Yeah.
If we consider the Earth outside 10,000 kilometers outside of Earth, Helios, Earth's finished sphere.
Yeah,
it can let such a signals to come in the Earth.
Oh, you don't think so?
I didn't write in my article in connection to the LIGO, because I have the graviton waves before the LIGO. I have the graviton waves, and that is why when he announced that they discovered the gravity waves, immediately I read their article and know that is not can be real.
Yeah, but you're not alone in that. I think there was a number of people who questioned the LIGO results. I think though you can't say that the geomagnetic field of the Earth would keep out gravity waves, could you? I don't think so. I think they'd go straight through.
Two things can be happened, and not disconsider their tools, because they have a good tools, and it should be very good use in case of earthquake forecasting, the LIGO system.
Yeah,
in case of California, their tools is very, very good. And I think they have got signals from sun or from the inner of the earth. Perhaps from sun that happened sun eruption something, and this phenomena can appear on the surface of Earth like a gravity wave. If we have a solar eruption on a flare, we have a solar flare. It can appear on the surface of the Earth like an gravity wave. I have a friend in Canada who are making measurements only with scalar. I don't speak. I don't come in my mind. Scale.
It's like a Fabry.
Making some measurements. Will also send this article, and at him apparent it can be demonstrated this
okay, yeah, well,
he made a simpler. I will send and if you can have, I will send. I don't know how can I do his apparat, as it's good for two. It's for you too, because this apparat same can be used in case of earthquakes.
Okay,
earthquakes.
Maybe a Richter scale.
I will send, and I think around $2,000 you can make this system, but not have a tool. But you don't have need to put in the underground, and he in this case he thought that is a effect. That is more his experiment is more valuable if is outside, not into the house, and only to not be affected by something, by the wind, something, only this to be eliminated.
Gotcha. That's interesting.
No, what is in case of in the gravitational waves, that I think LIGO made something different thing.
Yeah.
And they get the Nobel Prize for that thing. Not announced for public.
Oh, you think so?
We made something good thing, but not what we know about. We have what we have information about their achievement. That is not this.
Okay. That's interesting. You have an interesting take on that.
It's interferometer, right? They use
some sort of interferometer. Yeah, you're right.
Something like a Fabry-Perot interferometer, very similar. Fabry-Perot.
It's incredibly accurate or sensitive. In fact, it's so sensitive beneath the nanometer scale of the wavelength of the light, I think, that they're using to measure the actual effect, which is a bit odd.
The differential polarization or something they use, I think,
probably
to make it into two directions and then measure.
Yeah, I'd like to go back to your point about the gravitons here, though, because I have some questions on that subject, or questions and just, considerations, maybe you might say, observations. So if we have, in quantum mechanics, I think they talk about a particle as having no extent. So it's zero size, right? Because if it had any surface area,
it has extent.
No, but I'm saying in quantum
mechanics, have extents.
In quantum mechanics, with the Bohr radius and
quantum in quantum mechanics, also it have to has extents. If
you're not right there. Sorry, there's like the classical radius of the electron or something like that. But if you're talking about
if you want described mathematically, you can consider, as you told, it has no extension, but in reality you have to think in two directions. One thing in,
well, I don't know. I mean, you might talk to Rajan there, and he could talk about
and in sense mathematical. In case of sense mathematical is correct.
Okay, 1 second though. Like, Rajan talks a lot about like vortices spinning. Now, something like that, yeah. Like, but if we're trying to like look at the research they've done and say, okay, well, mathematically they've proved that it cannot have a surface area because then it would break something to do with relativity, like the particle, the spin would be faster than the speed of light or something like that. So they say to get rid of that, they say that it has zero extent. So if you have like the point at the center of a vortex or something, that's going to have zero extent as well. So maybe that's what the particle is, and then the sort of the churning.
No, what they say is that particle can be described only in terms of wave function. So it means that, like a cloud, it occupies.
But that's the problem.
It collapses.
Yeah.
So that particle size becomes when it collapses. When it is not collapsed, it has no size. But when it collapses, it gains some size.
I don't think, no, that's not what they mean. No, because the wave function. Anyway, that's a different. Anyway, I don't want to get dragged off the point here. I just want to. Sorry, I'm trying to get to a specific point. So then you have micro black holes, and I'm just thinking like a black hole also has no extent in some sense. It's like it should be like a singularity in space time. So it should be. Everything is squashed out of existence in a sense, or at least pushed into the future, if you'd like to look at it that way. It's up to you. But then if we have a micro black hole, which are said to be created by, the Large Hadron Collider, when they were smashing protons together, there was this fear or danger that they might create micro black holes. And indeed, I think they say they do create them, but what happens is they exist for such a small amount of time and then they evaporate. So I think, if you're going to talk about the graviton being a micro black hole, and then this idea of no extent of the particle, which to me sounds like a micro black hole anyway, and then this evaporation idea, I don't know. I think all of these things need to be, how do you say, reconciled, right? Or just given a logical kind of categorization, so we know what these things are and how they interact, or do they interact, or are they all real? And then of course, well, it's interesting what Laszlo's saying about that you cannot have a cosmological black hole on a large scale. It seems to me that these cosmological black holes, when they collapse down into a singularity, that singularity has to be the same size for each black hole, because it's of zero extent. So they're all the same size. But they seem to be of different intensities, however. But spatially, at least, they should be all the same size. And then you wonder, we get back to the idea of fractals. Then, like, if it's the same size, then it must be atomic in some sense, isn't it? So you have this zero extent particle in the universe, and then you have this zero extent singularity of the black hole. So yeah, so what is the difference between these two? There's obviously far more extreme forces going on in the black hole than there is in the particle. So it's interesting. I don't know. I'm not really making an argument. I'm just floating out questions here. And
that's the idea that in the original with the Emmanuel, I have the original one, right? There are two things, something called 0 points. 0 points, they are different from micro black holes. These 0 point has only gradient. They are only gradient fields, whereas the micro black hole, they have the vortex fields.
Oh.
The micro black. So Helmholtz decomposition says that you can actually have the fields essentially are rotational fields and translational or gradient field. These are the only two possible fields. So the 0 point is like a cosmic micro whatever electromagnetic thing, which has only a gradient, and even gravity may only that. But the micro black holes have vortex, which means they have rotational things.
Wait a second. When you're talking about micro black holes, are you talking about the same things that come out of the Large Hadron Collider that evaporate? Or are you talking about...
It can, but it's more fundamental than that. More fundamental because in the superluminal level, micro black holes exist, or they come out of it because of the monopoles. So they are connected with monopoles. So when the monopoles are the most fundamental, and the monopoles come together, they can form micro. There are two things can form. One of them is the micro black hole. The other one is a 0 point. Okay, the 0 point.
What do you mean by 0 point? The 0 point energy of the universe.
0 point, yeah. 0 point energy means no.
0 point is macro in macro dimension. You can imagine, and how Ryan told you is in a micro level on the quantum level. Can you imagine
0 point energy? They're talking about, when you get down to the lowest energy level, there's still some energy there. It's like 1/2, and that 1/2 when you combine it over like all the wavelengths, whatever, it's like it's a lot of energy. But in general, they talk about it as virtual particles sort of zipping in and out of existence, borrowing their energy from the future, and that's what 0 point energy is. And so I don't really think that has anything to do with like a gradient so much, like on such a simple level. But I would have thought more that when you're talking about the gradient, you're talking more maybe like to do with a particle. You'd have like the force, the inward force, maybe the electric force of the particle, and then the curl would be the magnetic moment, so the spin of the particle, and then those two together, you could have, like in the case of the fermion, it's usually meant to be some sort of space-time warpage. Now, anything that can warp space-time, especially in such a complex, knotted way, the only thing that I can think of that would do that other than a particle would be like something like a black hole. So, and it would have to be a rotating, is a Schwarzschild black hole that rotates?
Magnetar type thing.
Right, because you can just have a simple black hole that doesn't rotate or one that does, and then you'd have like crazy frame dragging effects.
The curve type, and the other one,
Right. So it just seemed like, I mean, I've heard this before. This idea that there's like a very serious kind of similarity between quantum particles, subatomic particles, and black holes. But obviously, there's obviously a big difference.
In case of macro scale, you can speak about singularity. Only on the micro level. I have forgotten to tell you.
Well, this is your point, Laszlo, and I think it's interesting. But I don't know if it's true. I mean, you would have to like sort of explain that to me a bit more before I would start to see your point of view. But I have heard in the past that someone said you could only have one singularity in the universe, like a macro one, and I don't know what the argument for that is either. I mean, I can think of one, but I don't like to, I don't like to put words in people's mouths or whatever. But Um, yeah. So what's your point of view? Why do you think there's no such thing as a macro black hole?
Because, as I told you, in case of geology, we have to observe only directly the nature, and we have to get the conclusion from this what we saw, and such a long observation of the nature gives such a conclusion. As you get you go in bigger scale, something other thing happening, like in case as we go in smaller scale.
Yeah.
And that is very important, you know, because of the my concept of graviton. I cannot explain why the chemical connection exists between atoms, and with this can be explained. Example why the nickel copper has 2 and 4 valence. It can be explained when in school has had taught that the structure of the copper, and it came out that it have to have only 2 valence, and but the copper can have 4 valence, and in different other elements the situation and same, and can be explained with this knowledge. And in case of the graviton, and in case of Ryan concept of the micro black hole, this can be explained.
Yeah, I wonder. I'm not so sure, but it's interesting.
You don't need sure, and perhaps by the time, perhaps you will understand. I am thinking only in sense natural. I am on sense what I saw in the nature. Mathematically, I abandoned mathematics when I have 20 years. I think I told you well. I abandoned the mathematics because mathematics has its it cannot get the nature. How is it? Only in a minimal part of the nature can be get, and that, but the mathematics is good.
Yeah.
If you can the catch it part of nature to put it in the good place. Do you understand? Okay. If you cut something from nature, and you know where you have cut with your mathematics.
Yeah. So it's interesting, but I suppose going back to your earlier point, so we have the natural world, like let's call it the mesosphere, mesoscopic level, and then we go down to the micro quantum level. There's different rules down there. Yeah, I think you were saying. So, but wait a second, I'm not finished. And then if we were to go bigger, then we would expect what? The rules to break down again in a different way. Is that what you're suggesting? But I'm
not really works different. They will similar. Only the dimension is different. The time is how we go outside. how it does will increase, the time will become will come will come végtelen. No.
Yeah, vector.
Lower?
That's what I'm saying. Yeah.
Faster?
6 vector.
Slower?
The time actually.
I am dilating.
Dilating.
I will write down. I don't know exactly, but it comes without time. And if we come to the quantum scale,
yeah,
it will have similar. I have wrote a philosophical essay about this.
Yes.
It is on the ResearchGate, but in Hungarian.
Okay.
Exactly this thing, because we don't have time. We have a singular time on the dimension of quantum level, and we have an extended time in case of is the bigger scale, cosmical scale.
Oh, interesting. So you're not saying that the time on the cosmological scale is the same type of time?
Exactly. How is it? How is it? Is it increase the time? Is become? I don't find the
words.
The words exactly, but the problem that the cell phone has not current, because immediately I will look onto the computer, but I don't have.
No problem.
I am far from the computer now, because I don't have current. No.
Well,
okay. If we go in the quantum level, there we have a singularity. Null time. But what is the in case of how we go outside? Will be such a things. I am give the sign of the time.
Oh, infinity.
Infinity, exactly.
Yeah.
That the time will become infinitive.
Yeah. Okay.
And in such a case, in a multipolar cosmological system, this works. Not with Big Bang created universe, because now as I observed that this thought become changed a bit.
Yeah. Okay. So well, like in the standard cosmological sense, if we talk about a singularity with general relativity, if you have something that's like a singularity, a gravitational well, that's like that, like a singularity, it becomes time stops. Yeah. So it's kind of like no time, eternity, infinite, if you like. But then you're saying on the large cosmological scale, also
and if you see, in this case you can use mathematics too, if you want to describe this situation, because you create a simple function, and in such a case only to the time, and in this case you can describe this situation.
Well, to be honest with you, Laszlo, I think you're right there, because what I'm trying to say is that what you're suggesting dovetails, like agrees very well with with my research, because I have a theory of a 4-dimensional hypersphere, and the entire universe is on this hypersphere, and it's projected onto a plane, a bit like Mercator projection or polar coordinate projection of a map. And but on the hypersphere, so you just think of a ball, at the top point where the projection is, everything gets way smaller. So at a certain point, even though they're galaxies and stars and stuff, they will cross the line into a quantum realm. So and then at that point, it's basically saying that the biggest furthest, biggest, largest structures in the universe are actually exist beyond the when I say biggest, I mean like furthest away, but they're also very big from our perspective. Will exist beyond this quantum limit, like not even the Planck scale, but something else. Doesn't have to, like, it could be larger or smaller than that. Well, probably larger. But so the point is that if we had a telescope strong enough to like really look far back into space or far out into space, if you like, at a certain point, the objects there should start to behave in ways that we just have no physical explanation for. I think we're already beginning to see that from the JWST James Webb Telescope, but I'm not sure if it's quite on the level of what my theory predicts, but possibly. Anyway, so that's just a few thoughts there on that. I'd agree with you on but maybe for different reasons. So maybe we don't agree entirely on everything. That's okay.
Yeah. But on only one remark, if you scale increasing in sense geometric, yes, we can speak about the sphere, because if you imagine an totally infinitive sphere, the sphere can be accepted like a cube. No more. We can speak about sphere. We have a simple Greek geometry. How is taught this geometry of Greeks?
I agree. Geometry. I agree with you. Yeah, the Platonic spheres and
Greek, ancient Greek geometry. I don't know.
Euclidean.
I remember. Yes,
not
yes.
Euclidean.
Greeks
yes.
Geometry. Euclidean, yes. Euclidean geometry. How is the sphere increasing? We will have Euclidean geometry. How the sphere will decrease? We will not have Euclidean geometry. Perhaps I don't know. You are mathematicians. We go in sense of Riemann geometry.
Right.
I don't know. I told you, well, I don't know.
Okay. Yeah. Fair enough.
How the sphere, the space is increasing? We go in sense of Euclidean geometry. How the scale is decreased? We go in sense of the Riemann geometry.
Yeah, I mean, is Riemann non-Euclidean? I know it's complex, but
spheric geometry. Spheric geometry.
Oh, sorry, like hyperbolic geometry.
Yes.
Yeah, and Riemann spheres, or well, not Riemann spheres. Sorry, Riemann geometry, like the metric, what you have in general relativity, those are hyperbolic curvatures, right? So I think even on the large scale, then, when you're talking about a planet or a star warping space-time, that should have some sort of non-Euclidean.
But in case of this explanation, I have found same natural explanation of this theory, because it's totally geometrical explanation, and he rejected the real space. They rejected the ether, and without ether we cannot explain gravitational effect.
Yeah. So that's another thing. So if you were asking about the sphere that I'm talking about and how could it be in a Euclidean thing, like, I would agree with you on that, because I'm not saying the sphere is infinite or anything any more than, like, if I were to take this length and cut it in half and then cut it in half and keep cutting it in half, I could do that infinitely, technically, you know? But that doesn't mean that this length is infinitely long. Similarly with the sphere, it has a a finite distance, semi circumference, finite, but you can divide it up smaller and smaller. And so as you go up the sphere, the particles just get smaller and smaller. Time gets slower and slower. So once you reach the antipode, the top of the sphere, time is stopped completely, possibly. But there is in cosmology currently already a theory that's very similar to that. It suggests you have like a closed universe, and then so the antipode in this sense is some sort of point out of the universe that doesn't exist, but it's you have this expanding space. So in their case, I think I agree with you. Their model is talking about a sphere that is not a sphere. It's constantly kind of growing, but it isn't really a sphere. So I would dispute their model. My model, though, has no such problems on that front, but it could have many other problems on many other fronts. So I've given up like claiming victory on my my model. I would try to be a bit more humble and say, could be wrong, but there you go. It's called the anamorphic. Well, it's actually recently had a name change to the anamorphic perspective cosmology, because there is actually, it used to be called the anamorphic universe model, but that's not a great name. So, and there is already something called anamorphic cosmology, which I was kind of excited to find out about, because I was like, oh, maybe somebody else is also talking about the same thing I'm talking about. But then I looked into it, and it's completely different. It's something to do, I'd have to look it up again to be fully sure, but it's something to do with, do you know about it, Rajan? It's like the Big Bang, and oh yeah, it's something to do with smoothing out the waves by having the universe expand and contract at the same time, and they're calling that anamorphic something or other. But it was nothing to do with my current model. It's very different, because I'm actually dealing with actual anamorphic perspectives, and that is accounting for the increased redshifts of galaxies further the way they are from the Earth. Yeah, so that has actually reminded me that recently some Greek? No, he wasn't Greek. Sorry, he was. I'm not sure where he was from, but some theorist has recently come up with a new theory of the expanding universe, and he thinks that the reason why we see redshift is because light is slowing down in these voids, and that's giving us the sense of redshift or greater redshift when it's not really there. Have you heard about this? It's very new research. Maybe this is passed by, but
like a diffraction or something like that. Is it like a diffraction? Like a diffraction?
Yes, I think so. Yeah, something like that. No, I think it's to do with time dilation. So as it's coming in, because gravity causes time dilation, and because
Doppler.
Yeah, something like that. So because the void is there, it causes less time dilation, I think is his point. And then when it shifts, so it begins to shift. And then I think maybe when it's coming back into the Earth's gravity, it creates, you know what I like?
Illusion. So it's an illusion.
I would have to check, but I'd have to look at it again. But I wasn't very impressed. So I didn't, when you come up with something and you're like, yeah, that doesn't convince me. So I didn't dig further into it. I just kind of threw it away. So I haven't memorized his theory or anything. But, it's been touted as like the new theory. But I think it's just because they're...
Yeah, light is very tricky, Light is very tricky. It can do many different things. So what Laszlo was saying and you were saying, I have the previous publication about the sense giving the field effect. So the quantum level, it doesn't give field effect to time. So time is hidden. You cannot see time. In the mesoscopic and the space, it does give space. In the same way, the astrophysics, same thing. The sense doesn't give time effect to the field effect to that. But in mesoscopic, it gives both. The time and the sense gives both the field effect to space and time. That's why we are little bit by time aspect. So
Yeah.
the like you mentioned, it could become infinite, whatever, the astrophysics level all disappear altogether, because it
Yeah, that's
becomes.
interesting.
So I think
So
we
maybe I
are
could
all
look at
very
it in a
similar,
different way.
different explanations, but I think we have a common thing we talk
Yeah, yeah.
about.
Interesting. I like to consider your research as more kind of metaphysical, but I think there's other aspects to it as well that aren't so metaphysical. So I don't know, but I mean, it is even the metaphysical. Just even forgetting metaphysics and coming at things from a metaphysical point of view, which I guess you do as well, Laszlo. If you're more about intuition and less about maths-based stuff, you probably go into that camp a bit more.
Math is important. Math is important.
Yeah.
Is important, but after I have preoccupied with geology, and that is why I have to give up with math, because I have to give more experience in observation, in empirical empirical approach to the nature.
Yeah.
And before I have forgotten, and as I told you, that is how the scale becomes smaller. We have spherical geometry, but we will give a cut inside. We go back in Euclidean geometry. Do you understand? When we could inside, and we can have same Euclidean geometry.
Yeah, are you talking about a cross section or something? Like if this is a sphere and then you cut it?
We are going small. We have sphere, but when we cut or when we example smaller sphere, will create a crystal. There come back Euclidean geometry. Example, in case of matter, how we know the matter in around of us. It use Euclidean geometry. Example, in case of crystal, but it exists some similar some other case when doesn't use Euclidean geometry. Example, in case of Chalcedony, in case of a gate. If you see a gate, they have same spherical geometry. That is why the nature has a lot of different way of development. In different cases, it use different approach. Phenomena, same phenomena, but in other way. That is why there is the problem with math. Math only limitate the phenomena. I got the correct word, limitate.
Yes.
It's a limitation of the reality. Every time when you make mathematics, before what article sent me Ryan, there he used a correct tools with a function there that exactly resolve this situation.
Yes.
Not exactly resolve this situation, and very good resolution was. But one thing, you have to can be able to separate exactly the signal. And before the video, I told you that when you observe the signals of seismic signals, electromagnetic signals, or gravitational wave signals, you have to know where the information comes. It is very important because all phenomena around of us is like a movement.
Brownian, yeah.
Lot of Brownian movement. Exactly, in my concept, the universe exacts something similar.
Einstein
exactly like a Brownian movement.
Yes.
And I get another important word, that multipolar universe we have.
Yeah, and thank you for your comment. I am going next paper or further down. I'm going to work with Christopher also, because mostly I'm done with time. So I will work with the space, but I will consider you know, I have your comments. Thank you very much. I will consider that, because you did a critique of my work, and it's very useful, because I'm going to look into more and then apply it when we are developing, you know, the further theory.
And this work is very, very important. I have only one problem. I don't never heard about this mathematics. Never heard.
What?
In the work, but as how it was described, it very, very well can be understand that what is about this, and I have an opportunity to observe where can be used. It has a very, very large useful place. What have you worked out? And it's very, very, very important, because it can be used in everywhere in the industry. In the practice, has a and Christopher, you can use in your work too, in case of earthquakes forecasting too.
Oh,
Ryan.
I'm not sure. Like quantum effects don't normally have a huge effect. Like, you know, you wouldn't, because earthquakes are so large. We don't really need to be too worried about quantum effects. Obviously, you know.
But how it connects? No. What I'm trying to do is, now I come from quantum, right? The time. Now I connect with your space, and at that time we'll see the connection. How it affects the larger things.
I'm not sure. I mean, I've been doing some connections between earthquakes and time, and you know, just
earthquakes and time.
I had like time quakes. I had like
earthquakes
predicted a different dimension, like a different timeline and stuff like that. But I haven't really released any of that work yet. So, but
earthquakes, we have to have times, because we have to say when will happen, and we only determine the signals, electromagnetic and seismic signals, in time, related to time.
Yes.
That is why time is very important in this case. And this case, the Ryan described work is very representative. Is made interpreted in connection to time.
Yes.
Yeah, of course. I'm not sorry. Which part of Rajan's work are you discussing here now? Because just to be clear,
I think he's talking about the signal and the time aspect. The signal, how it varies with the time. So one paper I talked about
signal.
The last paper, I think there are like.
Yeah, I don't know. I mean, what, like the signal is some sort of abstract thing, is it, or?
Yeah, from abstract, you see that from abstract I connect to the real things, right?
Yeah, but I still haven't figured that part out yet.
We will discuss that.
You showed some data that you generated, but you haven't. You know, you need to start using real world data to show that your method actually.
That's what the particle thing will help. The particle.
So, you've got a method, but you need to use real data to show that it actually produces anything meaningful, and therefore is a real method.
No, but, the particle. See, the particle thing I proved.
I mean, you know, this whole idea of vortices with particles and things like that. You know, that's like an old kind of concept, and I think it's probably a valid one. That's been going back a while, so it's perfectly fine to sort of build a theory of something like that. But I don't think, I mean, I don't know if it would have much of a impact on earthquake prediction. I think if we're going to bring in quantum effects for an earthquake prediction, we'll probably have just way too much data, because there'd be just no way to even model all of that data, you know, without like a quantum computer or something, some vast memory banks.
Yeah. One thing you can use, one concept of time, what my thing, I mean, I have to think about that based on your thing, right? Because I'm coming to that step by step, right? But one thing I can think about, you know, in the future is how the time acts. The time goes inside, the time disappears and comes back again. That is the ultimate thing. So that will explain why we cannot always detect things. I'm saying, thinking very aloud, but I have to connect them.
Well, there is a connection there between the hyperbolic realm and the hyperbolic realm and time. We've looked at that before on this program or this live stream. Well, you have a circle with 360 degrees, so that's Euclidean. But if you increase it so as more, then it becomes non-Euclidean. So imagine like every tiny amount of time, the circle's getting slightly bigger. But that's not allowed in our universe. So it snaps. But when it gets slightly bigger, it has to there's a space created, yeah? But the universe doesn't allow for that space to exist, so it slams it closed. But in doing so, it pulls it needs to get matter for it to close that. So, but it pulls the other matter over, and it gives this, and it keeps doing that. So it gives this effect of movement. So it's like if you were drunk or something, and you're standing there, and you kind of feel like you're leaning to the left or the right, but you feel like you're going to fall over. But your body keeps correcting its position back to where it was. So you aren't actually moving. You're just oscillating in place, sort of. So, but it feels like you're falling constantly. So something like that effect. So it's an illusion. Time just moves on. Because
Christopher, what you're talking about.
Now you have thought in a correct direction. Yeah. It's correct, Christopher, how you thought this thing.
And of course, this wavering back and forth motion, it kind of relates back to, isn't there Kundalini experiences, and then like it's related to this kind of concept of the snake and time.
Yeah,
time is like a snake as well; it eats its own tail in a sense.
Exactly.
So we could be getting something there.
Yeah, we are getting somewhere. No. Christopher, what you're talking about, when I was in school, I saw something about a Brownian motion. They talk about a drunkard going to a light pole and how it hits. They give a nice explanation of how the Brownian motion explains that.
Yeah. And Rajan, I was thinking there the other day, now I was sort of sitting down and I kind of had this weird vision, and it was something to do with motion through some part of the universe, like the higher dimensional realm of
Brownian motion can be explained with the same with ether, with the continuum ether can be explained, not with the luminal ether, with continuum ether.
Einstein
the Brownian motion.
Actually, Einstein's first thing was Brownian motion. When he was in Switzerland, in Zurich, he was with a person there. I forgot his name, physicist. They talked a lot about Brownian motion. That's where he started the whole, Einstein.
Okay. Well, that's very good. But but Brownian motion was obviously discovered by some guy called Brown, was it? Anyway, it doesn't really matter.
I don't remember the name. Yeah, I don't remember the name.
But okay, so anyway, I had this kind of vision of like this higher dimensional realm with like a lot of gold in it. I forgot. So it must be to do with hyperdimensional, maybe connected to the 120 cell model I'm using, which is that each one of those go at each moment there's like a thing being sent out, like so each moment of time. And but weirdly enough, I just had this vision of like a god with like multiple arms, but it was like because like he'd push like a second of time, but then his arm would come back and push it again, but it couldn't have done so because the other arm would have already been out at infinity, kind of thing. So it was obviously like a multi-armed god, like
Hindu mythology.
Simple said fluctuation of the space.
Possibly, yeah.
Simple say.
What is it?
Yeah.
But yeah, so anyway, it just reminded me of, is it Vishnu or one of these gods? And
yeah. No, our gods have many arms, like Brahma, Vishnu, they all have multiple arms.
Yeah.
And so they determine, various things they can do. You'll hold one thing there, one part of the earth, the other part of the, like a globe, another conch, which represents the sound. The other represent the light. And so different arms hold different parts, like fire in one thing, and earth in another thing. Yeah, elements.
Yeah, interesting. Okay, so I think we'll leave it there then. That's been like an hour and 40 minutes. So that's quite a long time, right, Laszlo?
I am very tired.
Yes. Yeah. And thanks a million for joining us. It was very unexpected.
It very nice, Laszlo. We enjoyed it. No, you connected our research.
It was hard as we have to thanks to Christopher.
Oh yes.
If you then if you then do that you did perhaps I don't have lucky to connect.
That's it. We were persistent, and
thank you for your pressing.
No problem. So we didn't get through too many Vixra papers, but that's the way it goes.
Interesting. That's interesting. Vixra papers. A lot of interesting things there.
Yeah, you can.
I wanted to write an article about ball lightning. If you have some simple articles, can you send me?
Yeah.
I want only very small article I want to write because I don't have time.
Well, do you know about like lights?
Perhaps I have an original explanation for ball lightning and its connection to the article which with this not empirical is metaphysical terms what I created. Perhaps is a cryptography that with a priori entity.
Okay.
Did you read it?
I don't think so. I haven't seen this. Oh, is it something you said?
I put it down. Someone offered that it correct it, but he didn't it. And after I read the translation, and I don't care that it has linguistic problems or not. And I shared. Perhaps Ryan, read it.
Yeah, do share it, but I haven't seen it. To be new to me. So.
It's the late article. It's what I have written in Hungarian.
Oh, okay.
I translated it, and perhaps that is created a very hard problem for me because I have worked before Christmas 2 weeks. I have worked too, and
very good.
And all, but these things only if we have luck to meet personally. There can I told about it.
Oh, well, great! I mean, we'll be in Hungary at the end of May, so that'll be the perfect time to meet.
Because there we are not in leave. We can discuss in different way because it cannot sell everything. Can speak about.
Okay, well,
no. And if you have something in connection to some work, good in connection with ball lightning,
okay,
it should be interested in me because perhaps is I have a resolution. It's not the best. It's every time it has to be demonstrated practically that if something is good or not.
Well, this is
it have to have a practical use. If you have a theory, if the theory have to have a practical use, as in case of Ryan, and in case of last with the last before 5-10 minutes you have told something, you have to continue and develop that thought because it's a good. I am feeling that you went in a good direction.
Oh, with the circles and stuff.
Yes. It was with radian and with the time.
Yes.
How you concepted the time with radian. That is a very good direction.
Yes.
Oh, the idea of the hyperbolic.
Yes.
Yeah, actually, I came up with that a couple of while ago. There's a couple of different. I think you can, if you watch back in our previous. I'll probably be able to find the video and I can send it on to you. But over the years, I've sort of refined it, and it's getting more. It's getting better. But yeah, so one day it may form a good solid basis for time.
And only one thing in sense to earthquakes. You have made a video. I have see with what you did. I will send you the Valentino Strasser's works.
Oh yeah.
And try to make connection with your tools, because if you can connect it, you will get a better tools.
Okay. Yeah. Yeah. No, that's always good.
It is a good thing I have to do, because I didn't saw at others source. I didn't saw such a thing with you did. Do you understand? And you have to develop your thing, that the signal, what you to get the intensity of the signal. If you can draw in the graph, the intensity of the signal. And as I told, and your tools is good for use in case of the Valentino Strasser's tools, because combined these two methods, then we can get the intensity of the signals. Is a very important thing. We have measurement of the intensity of the signal.
Oh yeah. Well, that sounds good. And I'll definitely look into well, when I'm thinking of ball lightning, it reminds me a bit of earthquake lights. You know that phenomenon.
Yes, it's not perhaps.
Who knows? They are connected.
I didn't. It's a good question. I didn't think about this.
There you go.
And this was it was a good imagination.
Yeah.
Because when finishing an ball lightning, similar phenomenon like in case of earthquakes.
Yes, right.
It was a good point.
Yes, so it could look. I could might be able to dig something out about that earthquake lights. I know.
I will write down this thought because I didn't thought about this and can be connected.
Yeah,
perhaps.
Yeah.
And I propose you same notice this your statement what you said about the ball lightning.
Yeah,
is a good point.
And then, of course, the Hastellan lights is another sort of thing, but it's not totally a million miles away. You know, Hastellan up there in Norway, but I don't know if you're familiar with them. But yeah, okay. So I think we should leave it there anyway, guys, and might chat to you next week. Rajan, you're doing History of Physics 10, is it?
No, that's February 15. I will do the History of Physics, the last one, the 10th episode, last one. I will do on the 15th of February. That's where it is done. But hopefully, there is no clash, I think. I don't think there is anything else coming. So, and then after that, we'll have documentary movie. I have some, we will discuss about that.
Okay. Well, that's your project.
Yeah. But I will discuss some of it, you know.
Yeah.
To get your idea, get your feedback.
Well, this is it. I was meant to do a presentation this week on, today on something that I've been working on, but my work is getting a bit too complicated. Week. So I don't know when it'll be ready. We'll see. So I there's no clear-cut thing for next week, but I could.
Yeah, I'm not sure.
We can do these 3-minute to 10-minute presentations that we did last time.
Yeah.
I don't make presentation.
Yeah. I might if there's
perhaps
time,
I don't have I have no time to prepare the work.
Okay.
I don't have time because I can't speak here. But if we have a direct contact, I can speak why I can do.
Okay.
Do you understand something? What is the problem?
Yes, of course.
Is connection before the connecting? As I told where I was and why.
Okay.
And I come back only at the 3 a.m.
Yes,
clock.
I hear you.
I late 1 hour and half hours. That is the problem.
Well,
every time if I will make this project or I can make a project for the a priori entity if you accept. It's totally banal thing.
Sounds good. Yeah, it sounds
and
really good.
and I can do about this some work, and the problems I am staying in 2 different places. There is I don't have table, but I do something to can show the image, and I will ask you to describe me what tools need to can project the presentation.
Yes. Yeah, you just send me the presentation on the images, and then
what tools need to will be showed to give an image about this project.
Yeah, no problem. I'll send you on details about that over the messages in ResearchGate. Okay.
Okay.
And we will sort that out. That's no problem.
So about a couple of clarification. Next week, there are some people coming, visiting here. So I'm not sure whether they come after that. So, but we may have a very brief meeting, if at all.
Oh, that's okay.
Or we may not have that. We will keep in through the email.
Okay.
And then I will also add Laszlo's email to our system, our group email.
Oh, good idea. Yeah. Okay, I'm going to end there.
Okay.